So the last superpower I want to talk about, and this is the biggest one in my opinion, um, is that it really helps decouple like an external system and your big ball of mud. So one of the biggest problems I said before is that in our industry is that a lot of systems, as it becomes more complex, are going to become like a big ball of mud. And in a sense, this is kind of natural because as your system becomes more popular, um, the systems and more systems and teams will like to use your data. And as more systems use your data, it'll become easier and easier to develop like a strong coupling and dependencies with these systems. This is going to start bog down like your pace of change. So let's go back to the example like for the tracking system. And remember, it has like its popularity has gone through the roof, and a lot of people are using it. So remember that this is a non-temporal table that only stores current state. And so this table is being used by like a head of analytics, used by the mobile team, shared with all the users across the world, used by CEO, people in and out of the company. So say one day, the head of analytics came to you and wanted you to help calculate the distance per trip. So with what we have here, there's no way he can collect this data. So we have to add a new distance field to this table. So the next day, the CEO came and wanted something to change, like something changed with his financial report. He wanted to only include trips that were completed and not canceled. And so, well, he's the CEO, so that got added after an overnight hotfix on the same day. And eventually more and more columns are added kind of this way to the table, and things are starting to get out of hand. The first problem is that there are now a lot of fields in this database that is not applicable to you, like, or the original intention of this table, and also to the other teams who are sharing the database. And these fields are confusing, like you and also like your other users. The second problem is that it's now becoming near impossible to change the definition of these fields. Imagine your team comes and tells you that, okay, it's actually not a good idea to store locations like in coordinates like J2, A5. Maybe it's more useful to use like a longitude and latitude. Like, who would have thought of that, right? Well, if we're gonna do that, like users are gonna be like super angry because they have spent millions of dollars investing on solutions based on that field, and any change is gonna put them behind competition for 5 years. So that's not good. So the third problem here is that any changes to the values in the table is also going to be very sensitive. So imagine there was a bug and the distance was miscalculated, and you were told by the head that, well, we have to retroactively update it so that it'll be corrected in his regional sales report. Well, this again is going to be a huge problem for downstream users because they've already reported on that previous value, and any changes is going to cause more confusion to their own current report. So the crux of this problem lies in the fact that the table is actually now strongly coupled with so many different systems, and they have their own concerns. So one solution like the industry has come up with over the years is to replicate the data and to transform it into maybe something that is more customized for each of the users. So in the early years, this was done through like exchanging interface files between a system to another. Later on, we use batch jobs like at a certain, like every night to automate the process. And more lately, of course, like we use messages, events, send over the wire through message bus and brokers. While this solves some of the problems, the external system are still going to be highly independent on your system, and no microservices is going to solve that because the problem is actually with the data model itself. So the problem with a lot of state-based models is that, and people don't realize this, is that it's actually tightly coupled with your core logic, okay? And because of this, consumers of the state-based models become dependent not just on your data, but also on your code base as well too. So let me explain. So in a typical modern application, like so the state is usually written by the database layer, but most of the calculation is made by the core business logic, right? So the update itself is triggered by user request from a user. So in this case, we move 5 kilometers to the east. Notice the state is actually calculated in the core logic based on its previous values and is updated. So as more requests comes in over time, the state is updated again based on its last value, and it overwrites it as well too. So eventually, like say the driver reaches its destination and the state is updated one last time. So a few things here you can notice is that first thing is that the final state is actually calculated from all the requests that came through one at a time. From now on, I'm going to call these requests user intents, okay? Because these are the requests, like the request came from someone's intention. And the second thing I want you guys to pay attention to is that we can also say that the state is dependent on the core logic itself. The state, okay, cannot be updated or calculated without the core logic. And so based on these two observations, I can say that the state actually is dependent on the core logic as well as the user intent. This is a huge this is a huge thing to notice. And if we zoom this out a bit, what we realize is that the downstream systems are also dependent on these things. And this is the reason why it's so difficult to change and update your core logic, because the whole world is dependent on this one little piece, okay? So I call this an intent confused state, okay? Because the state itself is actually calculated from all these intentions, but they're not stored and it's lost in the process. So it's like the guy from like if you remember Christopher Nolan movie, Memento, right? It's like the guy who like lost his memory and only has like his recent memories to go with. So there are many problems with these kinds of states. One huge problem is that we destroy the original intention when we update the state. This means that there are often multiple meanings to the same value in the state. We kind of talked about this earlier before. So for example, like a streaming service, does a active subscription doesn't mean that it's like an expired subscription was renewed, or was it a new sign-up? For vehicle rental service, does unavailable status mean that it's under maintenance, or was it actually reserved by a customer? For a flight reservation system, like when the seat is set to first class, did the customer upgrade it to first class? Or was the customer upgraded because there was overbooking, right? We may never know the answer to these because the original intentions were not kept and the state remains confused. And that's the first problem. The second problem is that these kinds of states, as mentioned, once it's coupled to the other parts of the system, it's very hard to decouple it. And the last problem is that like these states are often mutable as well too. So if we change some of these things, like they're going to be highly dependent, and any change to this is going to affect downstream systems. And so in general, we want things that are highly dependent on to be as immutable as possible. Otherwise, it's like building a castle that's made of sand. So how do we actually fix this problem, right? So A good way to do this is, first of all, right, let's go back to like so this here, we have like our intentions, we have our core logic, and we have like our status here. Okay, so what we want to do instead, we want to flip this around. And how to do this is that instead of storing data, we want to store the intentions instead. Okay, in a database like, say, like an event store. Okay, and then we want to make the intent confused state to derive from this instead. The projection, so the status, we call it the projection, can be generated from the events by calculating the states one at a time from the beginning to the end. And doing this already has massive effect on the flexibility on our system, because we have effectively decoupled the core logic from the data that we store. We have essentially turned this upside down and inversed the dependency between the source of truth and the logic. So before, the source of truth is dependent on the core logic itself. And now the logic is actually dependent on the truth instead. And since the truth doesn't depend on anything else, all systems that share this data, that actually, like all systems that actually retrieve this data, doesn't have to be dependent on your core logic anymore. And you're finally free to change the logic as you wish. So say, if the head of analytics come and he wants to change the definition of the distance, right? We don't have to like change it in our piece of data anymore. We can write him another piece of logic that calculates that, okay? And since you can calculate that with your events, you get essentially the same thing, okay? But again, you're not tied to the core logic itself. On the other hand, so if the CEO wants a status of the trip, we can create another projection for him. Okay, so none of these projections, right, depend on the core logic. And now if we want to change our location with like a, say, like a here, with different representations, we can also create our own projection with, say, longitude, latitude, but make it available like within our own app only, so that like other existing systems that want to remain on the old representation can continue to do so. So there are a few good benefits that come out of this. So as mentioned before, events are aligned to use the same language as business. Sorry, what I meant, so we can use this to build like a really high level performance cache, right? So see like the data itself, right? It doesn't have to be, it doesn't have to be stored in a relational database anymore. Like if we can flexibly change this, why don't we just store it like right at the edge, like right next to the client and in the cache, for example, right? And it's tailored to like, say, the front end. So you don't really need to do like a lot of transformation to actually get that data, and it's going to be much, much faster to do. Okay. And again, you can also choose like any kind of downstream data model you wish. So like you can choose to project this into like, say, like a Neo4j, like maybe like a graph database. You can project this to like Elasticsearch if you want to do full text search on this. Okay. You can like do this like you can project this to like a data warehouse as well too. So nothing's stopping you to do that as well too. So there's all kinds of flexibility you can do with this. The developer's code is going to be much cleaner as well too, because now that we've kind of separated the logic between like other systems, we also separate the logic between the read, how to project like this model, and how to actually save the events in your database as well too. So this is kind of like the CKRS, like a benefit to that. And the result of this is that you're going to have like much, much cleaner code, and code that also you can distribute to like different developers as well too. And lastly, the most important is that, of course, like it helps business to untangle like that actual ball of mud.